So I approach a bank with money in hand. Now, since I'm bringing them my money, they can use it for their purposes. And since they have that ability to borrow my money, that's something that's valuable to them. They can make money using my money. So the expectation is that they're going to give me interest for the use of my money. Interests are going to be expressed as a rate where it's a percent, but it's going to be an annual percentage rate unless otherwise stated. Now, the term annual percentage rate has been called APR. And let's just say that this bank offers me, they have a sign of 1% per year. Okay, that is an R value. Formula for simple interest is I equals PRT. So I is, of course, the interest. P is the principal. Principal is the amount that I deposited originally at time 0. R is the APR, which is the interest rate. And T is the duration of borrowing, or the time of investment. Okay, so let's do a hypothetical calculation. Let's say I give them my money and they have the money for 4 years. And 4 years later, I'm going to come back to the bank asking for not just my principal, but the interests as well. So the total accumulated amount is called A. And they will calculate A by not only giving me my principal back, but giving me back the interest as well. So it has a formula of P plus I. As a graph, what that would look like would be I earn money as a straight line. The line that I'm drawing is the line for A, the total accumulated amount. Now let's say that it's 4 years later. Not only do they owe me the principal that I originally deposited, which is $100, but they also owe me this triangle here, the interest. And we have to calculate how much it is. So let's do that now with the simple interest formula, PRT. You got to multiply the amount deposited, which was the $100. You have to multiply the interest rate, but we change it into a decimal. Instead of putting in 1%, we have to put in his decimal equivalent, which is 0.01. A percent means out of 100, so you divide 1 by 100 to get that value. That's per year, though. It's an annual interest rate unless otherwise stated. Then we have to put in the 4 years. Then we can finally calculate that they actually owe me $4 of interest after those 4 years. So now that we know that, we know how much my account had risen in 4 years. We also have to calculate what that final amount is. So we want to add the principal plus the interest they owe me. And then I know that they actually are going to give me $104 back when I return 4 years later. Now there's another formula for A that we should be aware of. We can find this other version of the formula by substituting in the interest formula into I. See, normally I would go here, but I is also PRT. So you get that. We can factor out the common P in these terms, revealing a useful formula for a simple interest account, which is P times 1 plus RT. Let's see if it gives the correct value for me. In my example, 4 years later, I show up having put in an initial $100 originally, and then I add 0.01 times the time of 4 years, or me lending them my money. Do this on a calculator and you'll see it is also $104. Now here's the thing about simple interest that's important. The interest is always calculated on the initial principal P which is that $100 in this example. And as time goes on, we see a straight line. That's very different from compound interest. With compound interest, you can actually earn interest on interest. What that means is when the bank owes you interest, they give you the interest, and you can do whatever you want with it. You could remove it from the bank, or you could keep it in the bank and let that interest accrue interest itself. It's called compound interest. Let's say that instead of going to a simple interest bank, I'm now going to take my business elsewhere. I'm going to go to a compound interest bank. I'm going to take them $100. Now let's start our graph out with $100 of principal. Let's say that after 1 year, they give me the interest that they owe me for the year of using my money. And then they just deposit it into the account, making a new amount in the account. So if they do 1% on $100, that would be like multiplying your 100 by 1 plus 0.01. So basically, you're multiplying 100 times 1.01, giving you 101% of what you had originally. That comes out to $101. So they're basically adding $1 to my account, giving me a new amount of 101. Now, for the next year, though, the second year, they're going to give me 1% again. But this time, it's not on the original $100. They're going to basically pretend like I had just given them $101 a year before, and now they're going to give me interest on that amount. So what happens is the amount that they give me is larger than $1. It ends up being that you now calculate 1% of $101. So you get 101 times 1.01, which gives you 102.01. So they have now given me $1.01, taking me to a grand total of 102.01. Now, that might not seem like a big deal at first, but if they keep doing this, what ends up happening is the steps get bigger and bigger every time. And what we end up getting is a curve for your account. Instead of a straight line. And it's an exponential curve. Alright, so there is a formula for these types of accounts. It's based on this idea here. At the start of the clock, you don't earn anything yet because no time has passed. Then you take the 100 and you multiply by 1.01. Then you could be said to take the 100 and multiply by 1.01 squared. And then you could be multiplying by 1.01 to the third. That's basically the formula. You take your principal, you multiply by a thing called 1 plus RC, and you raise it to the number of times it's compounded. C stands for what is called compounding. So every time money is added to your principal, it's called a compounding. However, we don't use this formula as often because it's not as practical for the real world, so we will use a variation of it. P times 1 plus R over N to the NT is the formula I want to use. Alright, so what does N stand for? It stands for the frequency of compounding. The frequency of compounding for this bank is yearly compounding. N equals 1. 1 compounding per year. Which means once a year, they will take all that interest they owe you and put it in your account so that it can earn interest on interest. Yeah, right here, it shows various frequencies of compounding. The worst one shown here would be annual compounding. Then there's quarterly compounding, which would be 4 times per year. That has an N value of 4. Monthly compounding is 12 times per year, of course. And then we have an idea called continuously compounding, which means that the interest just always flows to the account at all times. Let's look at the difference between simple interest and compound interest as a graph here. So I'm going to go to Desmos and plot what would happen at these two different banks. One of them would follow the formula for simple interest, which is P times 1 plus RT. And so I put in $100. My interest rate, I said, was 0.01. And you leave T as a variable so you can see how the account grows with time. With simple interest, we get linear growth. But for compound interest, we're going to use that other formula I mentioned. 1 plus R over N to the NT. So my principal was still $100. The interest rate was 0.01. I said it was going to be yearly compounding, so N should be 1. And then I leave the T as a variable, but this time the variable is in an exponent position. So we're going to get exponential growth. Now at first, it might not seem like a big deal, the difference between simple interest and compound interest. But as time goes on, because we're dealing with exponential growth and earning interest upon interest, it does matter. And the differences between these accounts become so wildly large that they're almost inconceivable.